So in this problem, we have two charges placed on z-axis, charge q and charge minus q. The distance between them is 2a. The question is how much work needs to be done to bring charges from distance 2a to distance a, and to show the potential energy versus separation radius r. So here is my illustration to the charges, and to find work, so the energy needed to be spent to bring one charge to change the separation distance between them can be found as a force along the distance, in our case along z. Electrostatic force, the charges have a different polarity, so it will be attraction force, which can be written as minus q if we bring this charge here to change the position from 2a till a. It's the electrostatic force minus q times electric field along the way along which the force is acting. And electric field is electrostatics minus grad potential. So if we will substitute it, the potential is basically phi dz in z direction, because we have only z-axis and the point charge, so we don't have other unit vectors, or we don't have r or phi in this problem besides the potential phi. And the dl is so it's obvious that the force will be along z, and then the tiny path past piece of this path is d. And then these two can cancel each other, and we have left q in that direction, or actually our dl, yes, here is in that direction. So the force would be acting in the positive z, because we would bring the minus q, and then this time this is 1, because work doesn't, work shows the magnitude, the direction. So q, and here is left d phi. And this d phi would be between the two location points, 1 and 2. So from the original point where was the charge, where it's brought by the work. So in other words, so that's what I have for the work. So to find the work, needs to find the potential for the point 2 and point 1. Potential point 2 So where it should be, and potential on point 1 where it was. Potential for this problem. So first for 2A, can be found very easy. So it's a Q. So minus Q divided by 4 pi epsilon naught, and 1 divided by the radius of separation, which is 2A. And potential 1 and potential 2. And now we can find the work. Work is a Q, which in our case is a minus Q, times minus minus. Right? And then the answer is 32 minus 1. This way. Yes, this looks proper. So the answer is Q squared So that would be the work which needs to spend for the charge to come from one point to another. And what about the potential energy? The potential energy is the same as work. Potential energy. So the this is the formula for the potential energy. And then when the work is done, the energy is getting stored in the charge. So it's potential energy of the charge. And if we want to illustrate the relation of potential energy to the separation, this is separation radius. So how the potential energy is changing. And we have this formula. U squared divided by R. If we want to see it in relation with the radius of separation, and then since it's divided by R, the larger is the radius. Sorry. The larger is the radius, the smaller is the energy. So such relation for Q positive and mirrored for the negative.